So we're going to talk about refactoring to modules, why and how. All you need to know that was officially called in the hour, but then they told us we only have 45 minutes, so now it's less than an hour. And I think we'll be fine. Let me start with the most important slide of today's talk, and this is this slide. So we prepared a special page for you. It's on JFrog.com show notes. And you'll find all the information that you need to know about this talk right there. So the slides are already there. If you go there, you'll find a page dedicated to GopherCon, and the slides are already there. And the video is being recorded now, and I will upload it later today, so you will have the video by tomorrow. All the links are there, and there is a lot. We're going to cover a lot of ground with a lot of theory and what's not. You don't need to Google anything, or everything is just there. You go there, all the links. You can praise our talk there with comments and ratings, and also a small raffle just for thanking you for being here. Although, you know what, it's a single track conference, you don't have any place else to be, so we can skip the raffle. No, we'll keep it. That's fine. So with that, on every slide you have this URL in case you forget, you didn't pay attention, but you want to see it later, it's right there. And with that, let's introduce the speakers. That's Eyal and Moshe.
Hi, everyone.
And he is the lead of our ecosystem team that does a lot of work around the ecosystem to our products. And one of the most important ones is JFrog CLI.
Yep.
JFrog CLI is actually written in Go and has been refactored to modules lately. And I will share his experience in doing that today.
Absolutely.
And my name is Baruch. I'm head of developer relations with JFrog. And as you already figured out, you need to follow me on Twitter right now because I'm very entertaining. So our Twitter handles are here. Again, instead, if you're still not convinced, by the end of the talk, you for sure will be convinced. And our Twitter handles are on every slide as well. How convenient. So with that, let's get started. And to understand why Go modules work in the way they work, we need to go back in time. And we need to understand why some aspects of Go were designed in the way they were designed. So we're going to get back to very beginning, and let's see who actually remembers. So by the show of hands, who's here started Go in pre-1? All right, there are some hands.
Wow.
Okay. How about 1.2? More? How about 1.5? Okay, we get to the majority. 1.8, it's probably most of you. Any newcomers? 1.11? Yeah, all right. I think Natalie is going to talk a lot about newcomers and how they feel in their keynote. So yeah, there are a couple of hands that actually were there from the beginning. For the rest of you, let's go back in time and talk about that. So why do we have the problem that Go modules solve? We have it because of how Go was designed. That's actually a slide from Rob Pike talk about the history of Go. And he was talking about how they designed in 2007. And the interesting list here is who those people are. If you go and Google them a little bit, you will discover that all of them come from the same background, and that's C++ developers. And C++ developers back then had, in Google, had a huge problem. And this is how their build and their dependencies worked, right? So they spoke about one make file that built the entire Google, like everything. And then they later then refactored per directory build files, and that was a little bit easier. But the pain of dependencies was a huge driver in coming up with Go in the first place. Right? If you watch this talk, he's ranting about developers, about dependencies a lot. And obviously you know where to find the link for this talk? Right here. Right? Okay. So, and then they're like, you know what, let's do something very simple. Much simpler than we had in C++. All the dependencies will be sources. We will actually be able to remote import it from version control. We're going to merge all the sources together under a single directory. We're going to compile everything together, and that actually solves the problem. And it really does. Comparing to the hell with dependencies in C++, this is an ingenious, simple solution, right? The only thing that kind of take it closer to this in C++ world is Conan, but still, even with Conan, C++ is much more complicated. This is super simple, and this works.
I'm not sure.
Kinda. Because now we have a lot of questions.
So, wait a minute. How do I know which dependencies do I use?
This is a very good question. We have one source tree. All the code is there. Some of it are dependencies. Some of it are not dependencies. What's going on?
I have no idea. And how do I know which dependencies do you use? I mean, did you?
I imported some code from version control into my project. How Eyal can know what did I do?
I have no idea. I mean, and you know, and which dependencies should I use? I mean, what should I take?
Right, so we have a big project, we have a lot of developers, now we need to decide on dependencies, how we even start doing that.
Yeah. And, you know, when I'm working on the code, on my code, how do I know if I'm writing, you know, editing my own code or my dependencies? I mean,
right, so we have a com JFrog namespace, and there is some code there. Is it a dependency from a different team? Or is it my project that I'm allowed to actually change? And if I'm going to change it, what's going to happen? Generally, it's kind of hard to know what's going on. And you know what? Obviously, those questions been around for a while, and we are not the only one who asked them. And they've been asked to the core team of Go as well, and not only by us. So here's an example of Dave Cheney. He's kind of known in the community, and he actually said that resorted to an email semaphore to decide what to use. Right? They sent emails like, okay, do go get -u. No, don't do get -u because you will get something else. This is like a really, really horrible. And of course, imagine how successful this and how much time it's being spent chasing the bugs that we've been already fixed. And those questions were asked of the Go core team, and the answers they gave are kind of strange. Very honest, but probably not so good. So, Brad Fitzpatrick, check your dependencies into your version control. Basically, duplicate your dependencies. Basically, fork your dependencies. Or, Andrew Gerard, we don't care. It's not the role of a language to dictate how you manage your dependencies. Like, do whatever you like. And you know what? We expect you to already have dependency manager that you wrote in-house. If you need to do any tooling, well, we use standard things. Git, Mercurial, Bazaar. Good luck. Do your own dependency manager. Yeah. And Brad actually says, you know what? Go-get is not for production. It's nice to play around, but if you do something serious, like deploy into production, don't use go-get, because you are going to deploy no one knows what. And when those are the answers we get from the team, next thing that happens, community steps in. 19 here is not a metaphorical example. There are literally 19 different dependency managers. Okay, quiz time. Let's have some fun. Who knows the dependency descriptor dependencies.tsv? Which dependency manager works with it?
Come on, who knows?
No? No? Well, okay. It's go-deps. The descriptor go-deps.json. Which dependency manager works with that? Go-dep. The file called is go-deps, and there is a dependency manager called go-deps. That's not the correct one. Okay, out of the following list, which are real dependency managers? Go vendor, go vend, go ven, GV. All of them. That's the correct answer. Out of the next list, which are real dependency managers? Trash, garbage, rubbish. Which one?
Which is real?
You want to say all of them, obviously? But no. Trash is an actual Go dependency manager. Written by great company, written by forget the name. Rancher, thank you.
Yeah.
Yeah, so Rancher team wrote the dependency manager and they decided to call it trash. Okay, weapons manufacturer.
Come on.
Anyone?
Anyone in the weapons business here?
Glock, G-Lock. Actually pronounced Glock as the gun. Well, in the US that works better, this part. All right, so what's in common of all those? They all utilize two concepts which are provided by the language. And that's the Go path and vendoring. Basically, all of them do the same. They know how to describe dependencies and how to vendor them in a vendor directory, which is a part of a standard Go since Go 1.5. And this is a problematic solution both because Go path and because of vendoring. So let's talk about that. So let's start with Go path. Go path is the proud son of the monorepo. And if you Google monorepo and you go to the videos tab in Google, you will see 198 talks by Googlers and friends evangelizing how great monorepo is. Which you might agree or disagree, but they are very opinionated that everything should be in a single source code. And this is why we have Go path, which is a single source code.
Yeah.
And this is great, but there are two big problems. The first one is you can only have a single version of a given package under Go path. And you either switch Go path or there is no way around. The other problem is, we already spoke about it, you really don't know if the code that you look at is the code of the project or is it a dependency. People can reason about it, right? I can look at it and I can say, oh, that's not my code. But programmatically, there is no way at all. And that's a problem.
And I know a few people who cannot even recognize their own code. So.
But that's, after 6 months, most of us. Now, what is vendoring? You know it, but just for you to think about it once more. Copy all the files from some version, from one version control repository, and paste them into a different version control repository. This is vendoring. And what's wrong with it? Everything is wrong with it. You lose history, you lose branching, tagging, you lose all the metadata immediately. Pulling updates are impossible. You cannot do git pull and get updates from it because it's disconnected from the original version control. You will eventually fix a tiny bug. You will fix a tiny bug in your repository. It won't go upstream. So you actually did a very poor fork. And you will do that. Of course, space, that's the least of the problems, but still, I mean, why do that? And obviously, good luck finding which version of the code are you using. Because there is no history, there is no tag, there is nothing. It's just a piece of code. So, and we had this, we did vendoring for Go modules, and when I asked Eyal, okay, so you use this dependency, which version it is?
I had no idea.
And he's like, yeah, Alex took some code and pasted over. That's exactly what happened.
We needed the code, right? We didn't have a package manager. So the solution was vendoring. So we just took the code, put it inside vendoring, and now, after 2 weeks, we had no idea which version we were using.
Okay, so who can call bullshit on this one and say that's not how proper vendoring works? Anyone? Yeah, no, there are a lot of tools that actually do that and provide some kind of metadata, but there is actually a solution to some of the issues here, like this one and this one. Anyone?
You can comment which...
Yeah, no, commenting, of course.
Versioning in the import tab.
Thank you very much. I waited for his comment. I didn't pay him money. Sub-modules should solve this problem because sub-modules allow you to link a different version control into yours without losing this connection that creates so many horrible mistakes. But it's still wrong because you still have no idea what version are you using, and you have to connect each dependency as a sub-module manually. And now we have all the fun of sub-modules. Okay, frankly, who has any experience with Git sub-modules? Who thinks it works? Yeah, so...
All right.
All right, yeah. And obviously, yeah. If you have modules that depend on each other and are sub-modules of each other, good luck with that. Well, so this is where we were, what it was, like a year and a half ago. And now we need to do something. We have 10 years of go-get, which is horrible in any possible way. We have 19 third-party dependency managers that most of them do the wrong thing, and it's about time to fix it. How do we even start fixing it? And one of the genius things that the Go team does is the experiment. So they conducted another experiment, which is the go-dep experiment. The person in charge of go-dep experiment was Sam Boyer. Sam Boyer comes from a Ruby background, and he's actually a very good friend of Yuda Katz. So he knows a thing or two about package manager. And he was like, yeah, okay. Woke up one morning, rolling out of bed, and thought, you know what? I don't have enough misery and suffering in my life. I know what to do. I'll write a language package manager. And then he did a lot of research, and those are the outcomes. Those are the conclusions of the experiment. Software is terrible. People are terrible. There are too many different scenarios. Nothing will really work for sure. It is provable mathematically that nothing will really work for sure. And kind of the outcome of the experiment is our lives are meaningless perturbations in swirling vortex of chaos and entropy.
Awesome.
This is the go-dep experiment. And he actually tried to do the right thing, right? Working in project directories, solving the Go path problem. Local cache for dependencies, that's solving the Go path problem, and version declarations, solving the vendoring, conflict resolution, right? So he did the right things, and actually, whoever here have experience with go-dep, it's a very, very good dependency manager, right? It's written on the shoulders of giants. He learned a lot about, obviously, Ruby, that's his background, but also Java and NPM and other dependency managers learn from their mistakes and their successes. go-dep is actually good. But it failed on conflict resolution. So basically there are two approaches. One approach advocated by Sam Boyer was recognizing that problem of dependency conflicts is what called the SAT, the Boolean satisfiability problem. I don't know algorithm, that's probably why I'm not in Google, but he obviously knows, so that's kind of a very, very hard problem. And the solution to this problem is SMT. They also give 3 letters acronyms, so even if you had a slight change to understand it, now we can't. So SMT stands for, I have in show notes, satisfiably modular theories. This is how you solve the Boolean satisfiability problem. Now, very good, awesome. Russ Cox, who is now leading the Go project, didn't like it because what he was saying is that's not the Go way. it's complicated. It requires a lot of understanding. It has too much flexibility. We want to keep being easygoing language, even if we cover only 95% of the scenarios and not 100, but we want to be 95% simpler. That's what we want to do. So instead, he went with MVS, which stands for minimal version selection. Suddenly, those words I can understand. Minimal version selection. Makes sense. And SIV, which is also simple. Semantic import versioning. Right? Complicated, simple, Go goes with simple.
Yeah.
So this is why, after this experiment, which was successful, right? A lot of good stuff, we actually move to the real thing, which is Go modules.
All right.
This is where we stand. Okay? So let's talk about Go modules. And the concepts of Go modules is very simple. Everything should work as it worked before, from the user experience perspective, but solve the problems that we want to solve. So all we need to run is Go mode init. It creates Go mode file, but then the rest is absolutely the same. We add imports in the code, and everything just works. Which is kind of weird, because how it can work now when we have versions, when we have caches, when we have stuff, which is obviously much more complicated than just resolving the latest source code and putting it in our Go path. So there is some black magic behind it, and we're going to talk a little bit about it. First of all, this Go init does a lot of heavy lifting by taking the 9 most popular dependency managers out of 19 and converting their dependency descriptors into Go modes. So if you express your dependencies in any of those, they will be automatically converted to Go modes. You don't need to do anything. But the interesting magic is what happens to Go mode when you add import and then run a Go build or Go get. So first of all, Go checks the URL of your import. And if it is a URL of a module repository, it will download the module. If it is URL of version control, it will clone the sources, create a module on the client, and use the module. If it is a web page, it will look for a Go import meta tag, follow the URL in Go import meta tag, and do one of those 3, obviously, recursively until it actually can satisfy the dependency. Right? And once we found something, either it's a module or it's a source, now all we need to decide is what version to take. And this is very simple. We are going to select the latest compatible version tag using semantic input version. And this is where all of you go like, what? Every word in latest compatible version tag doesn't make any sense. Because who decides what's compatible? The answer is, let's rely on semantic versioning. Which is kind of a naive approach,
Come on.
I would say. But let's pretend semantic versioning works. And let's pretend everything that is released after 1.0 all the way to 2.0 actually compatible.
No.
Well,
No.
that's the idea.
No.
And the premise here is very simple. We define an import, and we go to version control, and whatever latest there, as long as it is a major under the same merger version, after 1.0, should be compatible, so we can take the latest for the first time when you add the dependency.
Okay.
But, you know, people do break changes. And even if they want to work with SameVer, and they change major version, how do we express that we actually want now version 2 and not version 1? And not everything, the entire history is backwards compatible. That's all very, very simple. incompatible code can use the same import path. That means that if I have a major version which breaks backwards compatibility, it has to be a different path. It's like we have a new product. It's like we have a new dependency. It's like whatever is not compatible cannot use the same path. So what we're going to do, we're going to add version 2 to the path, and then use it in the import path. It will create a different path, and everything under this one, which means everything starting 2.0 all the way to 3, is expected to be backwards compatible with one another. So if we assume that somewhere actually works, and everything within the major version is backwards compatible, this actually works. But what about if we don't have any tags? Why would we? I mean, most of the Go code in the world don't have any tags.
Right.
Because when we used the old way, we just import whatever had master or whatever it is to our version control, and that's all. There is a solution for that as well. We will generate a pseudo version. Pseudo version is version 000, and it has the timestamp and some part of the commit. Within 000, a new commit will win, assuming that it's kind of, snapshot trash, and it probably won't work anyway, so you should approach the author and actually ask them to craft version 1.0. But that's kind of a development time, and that should be all right. And this is where you ask, okay, that's a nice story, but what about when somewhere doesn't work? If we manage to release within a major version something that does break compatibility, then what? The answer is we can skip bad versions. You remember the minimal version selection? This is it. You can say, well, yes, everything in 1 should be backwards compatible, but actually everything backwards compatible only starting 1.3. So you can kind of limit the minimal version that you need. If you need even more control, you can exclude a version, and you can say, okay, everything is good except 1.3.5. Or you can replace a version and say, every time you try to pull 1.3.5, actually put 1.3.6. So far, so good?
Yeah.
All right. And now, the only thing that we need to talk about is the Go path. We covered the part of the versions. Now, from vendoring, we move into what the rest of the industry does, and that's a hierarchy of module repositories. And Go modules define an hierarchy of caches. It starts with the public modules repository as a top level caching. And then you have your organizational modules repository. And then you have your local cache. Note that your local cache is actually Go path. You used it for development, now it's just a place for caches. If there are any Java developers there, you can think about it like your .m2/repository thing. This is what your Go path now becomes. Right? So in going from the other direction, local cache on the developer machine, this is after more are resolved or built on a client, this is where they're cached. And this is Go path PKG mod, and it provides immediate access to your local machine, obviously. They're not shared, right? They are for your usage only, and they're not reliable as you can always wipe the cache for various reasons. Who of us didn't format their rm-rf on the root, right? So they are not very reliable. The next level that is more reliable is your organizational modules repository. For example, JFrog Refactoring Project Athens. If you want to learn more about JFrog Refactoring, our table right there. That's not a product pitch. It provides faster access. It's your organization and it's your intranet. And it provides reproducible builds as it caches the dependencies that you used once, and you will be able to find them again for build reproduction, which is cool. The downside is that now you have a server that you need to babysit. So it requires maintenance, backups, cleanups, and all the part of it. You can have it SaaS, but anyway, it's a server in your responsibility. And moving to the top level, those are the public module repositories, like JFrog Go Center, which again, we can talk about later. Google also announced the vision for a federation of public repositories, that it will be a lot of public repositories that will talk to each other, and there was notaries that will verify that whatever is there actually reliable, etc. And it provides fast access. You use CDN and these kind of tricks, and it provides reproducible builds as it caches the popular and requested dependencies from version control. And even if someone deletes their own project from GitHub or messes with the tags, replacing the content, whatever is in Go Center will rely there, and you will be able to rely on it. It's highly available. It doesn't require any maintenance. It doesn't require any maintenance.
Yeah.
No, it doesn't. And it's actually free, right? So that was the theoretical part, and now we have 10 minutes for a demo.
Yeah, you want to see something?
Take it away. Look what wonderful give I prepared for you.
Wow.
Come on.
Right.
Okay, and now we're going to do the most dangerous part of the entire talk, and that's switch computer Smith's flight. Because that's the, this is where the PowerPoint is, and this is where the code is.
Yeah.
You cannot mix.
Right. Okay.
There you go. Let's see if it works. Don't lie.
Well,
It works.
what do you know? It works.
Here we go. Perfect. Yeah, you need to do like duplicate.
This is something I should have done before the talk, obviously.
You know how I hate to say I told you? I don't hate it at all. I actually love it. I told you.
Actually, you didn't tell me today.
Yeah, I did.
You want to help me, Baruch?
Yes. After I mentioned that I told you, now I can actually help you. There you go. And what we actually need is mirroring. Ta-da!
Very
amazing.
Good. All right.
All right.
Okay.
Show us some code.
All right.
You see, there's stuff that I'm good at. PowerPoint, displays.
Cool. Okay, so let's just see, basically, in practice, what Baruch talked about. So let me know if you see it, that you see it clearly. So this is, now you can also hear me. So this is our JFrog CLI project. So now, as you can see, we have, sorry. Excuse me. So we have a project, it's like going back to the past, we have a project with the vendor directory, which basically has, thank you, much better. So basically our vendor has all of our source code. That's the way we used to work, okay? And basically what we wanted to do is move to Go modules because of all the reasons that Baruch explained. By the way, notice that we have here an internal module called JFrog client inside the code. So this is also something that we want to make a module later on, okay?
So that's kind of a monolith, and this is just a package inside the same project.
Exactly. Okay. So this is our project, okay, right here, and we basically we see the vendor directory right here. So let's just convert it to Go modes, okay?
Live. That's live.
Yeah.
Unbelievable.
Basically, yeah. So
never tried before.
Yeah. So in our JFrog CLI project, actually the main function is not at the root. So let me go to where the main function is. And there it is. Okay? So basically what I want to do is I just want to build my project without Go modules because I haven't converted it yet. So what I need is still the code path. Let's just see.
Can you use the top line, please?
Oh.
Yeah.
Let me.
Just to pull. No, just pull the.
Yeah.
Yeah. And just pull it up. Yep. More.
Better now?
Yeah.
Okay.
All right. Yep.
All right, so I don't have my go path configured, so let me just do it real quick. So I'm just
Yes.
a bit higher in a minute. Yeah. Okay, let me take it higher. All right, yeah. All right. Better now?
Yeah.
Okay. So, let me just add my go path and just build the code. And
No modules, vendor.
no modules at all. I build the code, and here I have like the outcome of my build right here. That's my .jfrog. That's my JFrog executable here. Now let's do the conversion to Go modules.
You have 5 minutes.
Yeah.
That's what it took in the real life.
Yeah. Okay, now it's deleted. Now what I want to do is convert to Go modules. So let me go back to the root of my project. And just like Baruch show, I'm going to do Go mod init. But before that, if you remember, there's no Go path anymore, right? The Go path does not, in the Go mod world, Go path is becoming the path to your local cache. So let me just remove my Go path. Sorry?
The heart of every Gopher in the world bleeds when you remove the Go path variable.
Yeah. Okay, no Go path. Now let's do Go mode init. And here I have a Go mode file right here. Okay, now if you look at the content of the Go mode file, you'll see that it basically includes no dependencies. Okay, it only includes the name of my module, which Go figured out from my my
.git
cache.
Yeah.
Okay, all right. Now let's fill it up with dependencies. So basically, all I need to do right now is go and build my code. Okay, so let's go back to where my main function is right here, and do go build.
And what actually happens now is this semantic version importing, you remember? We already have the import statements, so now Go will go to whatever is there, and we'll take the latest version of the module that it find or clone and build the module locally.
There you go.
And creating some pseudo versions for JSON parser and crypto, but actually finding tags for others. And I think we're done.
Yeah.
You want to show the cache to verify that it's there?
Yeah, absolutely. So since I removed my Go path, so if I had my Go path configured, that's where my cache would be. But since I don't have Go path, so the default for the cache is under my user home, and then Go, and then you have here under PKG.
You have mod cache.
Sorry. Yeah.
Go.
Actually, talking and typing is harder than what I thought. Okay,
And
here it is.
mod, and then cache.
And then you have all the cache here.
There you go.
Yeah. Now, if you noticed, when I did the Go mode init, nothing basically was added to my Go mode because my vendor did not. I only had a vendor. I didn't have any previous
Dependency
manager. But if I had, the Go mode init would do the actual conversion.
And the dependencies actually come from Go Center, because
Right.
this is your Go proxy configured, and
Exactly.
this is where the build was fast and reliable. And that was 5 seconds of product pitch. Meet us at the table. We have cool T-shirts.
Yeah, we
Thank
do.
you very much.
Thank you.